So in this video we're going to go over what quadratic form is, and then in two subsequent videos we'll actually solve problems that are in quadratic form. So the idea is with quadratic form is we want to start with an equation that is not a quadratic equation, but we want to find a substitution u, where u is going to equal some algebraic expression. And when we substitute u into the equation we have that isn't a quadratic equation, we get something that looks like it is a quadratic equation. Then we say that the equation we're working with has quadratic form. So in this example, it says, show that the following are in quadratic form. So here I have a fourth degree polynomial. So it's clearly not a quadratic equation, which is a second degree polynomial. But what we want to notice is that this equation can be rewritten. So x to the fourth can be rewritten as x squared squared, because the way that we simplify an exponent being raised to another exponent is we multiply them, and 2 times 2 is 4. So x squared squared is still x to the fourth. And then we have minus 37x squared plus 36 equals 0. So x squared inside the parentheses here is an algebraic expression, and we could say let u equal x squared. And then we go to the equation we're working with, and everywhere we see an x squared, we replace it with the substitution u. So here the x squared squared becomes u squared minus 37, and here I have an x squared, so I replace it with u plus 36 equals 0. And now the thing that I have looks like a quadratic equation, even though it isn't, because u is not a variable. U is substituting in for an algebraic expression. But we have an equation here that is in quadratic form because I can, through a substitution, make it look like a quadratic equation. So similarly, this one, which clearly isn't even a polynomial because it has these rational exponents that are not nice whole numbers. But what we want to recognize is that this first term can be rewritten. We can say x plus 1 to the 1/3 squared. And this is the same as the original expression here because, again, when we raise one exponent to another, we multiply the exponents, and 1/3 times 2 is 2/3. So it's the same expression but written differently. Minus the x plus 1 to the 1/3 minus 2 equals 0. And then what we could do is say let u equal the algebraic expression x plus 1 to the 1/3. And now everywhere we see x plus 1 to the 1/3, we replace it with u. So we get u squared minus, now replace x plus 1 to the 1/3 with u, minus 2 equals 0. And now I have something that, even though it isn't a quadratic equation, it looks like a quadratic equation, which means to solve it we would be able to apply or employ quadratic equation solution techniques.